Hello everyone, my name is Yanj Bansal and welcome to my ELP 101 project. My project is on operational amplifiers. The operational amplifiers are the linear devices that have all the properties required for nearly ideal DC amplification and are therefore used extensively in signal conditioning, filtering, or to perform the mathematical operations such as add, subtract, integration, and differentiation. This slide shows the diagram of the operational amplifiers. The operational amplifiers are also called op-amps in the short term. These op-amps have several pins and these are of great importance. The op-amps have the two input pins, non-inverting input and the inverting input pin. If the voltage at the inverting input is higher, the output signal stays low. Similarly, if the voltage at the non-inverting input is high, the output goes high. The output pin depends upon the input pins and the feedback mechanism used. These op-amps have two power terminals, the positive power and the negative power. These small looking operational amplifiers are of great importance in the electronics, which you will see in the next slide. Application of op-amps. The op-amps are used in a variety of applications in electronics. Some of the more common applications are as a voltage follower, selective inversion circuit, a current to voltage converter, active rectifier, integrator, a whole variety of filters, and much more. But I have found an interesting use of the op-amps, which you may also find in your daily use. So the next slide will be on this special device. Tank overflow alarm. You might be familiar with this alarm at your home, at your workplace. If you are not familiar with this alarm, the next slide would be on the demonstration video of this alarm so that you can know what this alarm do. This is a circuit diagram of this alarm. It has a 741 operation amplifier, a buzzer, and a red LED light. These are surrounded with the resistors and a probe. The 741 is used as a voltage comparator with the inverting input pin 2. I have told you that 3 and the 2 are the input pins in the previous slide, connected to a potential divider R2 and R3 so that the pin 2 gets half supply voltage. The non-inverting input pin 3 is connected to R1 and the probe B. So when the probes are free, the inverting input gets higher voltage and the output of the comparator remains low. This keeps T1 out of the conduction so that the buzzer and the LED remains off. The probes connected to the point A and B are kept near the top of the water tank where maximum water level attains. When the water rises through the probe, pin 3 gets higher voltage to the moist probes and the output comparator turns high. This triggers T1 and the red LED lights and the buzzer beep to indicate the overflow. This alarm is installed in the water tank that feeds your bathroom and kitchen with water. It prevents the water from overflowing by warning us when the tank is full. Let me show you a demonstration video of this. Water tank is full. Please switch off the water. When the sensors come in contact with the water, an alarm sounds off instructing us to switch off the motor pump. I hope you all liked my work. Thank you for viewing my presentation.